When I was testing the cheap soldering irons, I used a true RMS meter to measure the current being pulled, and I feel some of the irons produced more heat than the power I was measuring. This could very well be my wrong impression of the heat produced, but I did wonder if the meter was missing some of the current being pulled. I do have this fairly new Rigol DHO804 scope, and it does have a lot of math functions and measuring features. Most I've never even tried. But I thought I should be able to set this up to measure the power being used by the iron. I felt the heat this iron produced was commensurate with the power I measured, so I thought this one would be a good test for setting up the scope to measure the power. Now I have an isolation transformer for the AC line. I don't want to blow up anything, especially myself or the scope, and I will be measuring the current by having the channel 1 scope probe across a 1 ohm resistor that is in line with the AC to the iron, so a 100 millivolt reading on the scope will be a 100 milliamp current draw. The channel 2 probe will be measuring the voltage going to the iron and resistor, so the voltage will show a tiny bit higher than what the iron itself is actually seeing. The AC line voltage, the green trace, is not the greatest sine wave, but the current waveform, the yellow trace, looks like a standard light dimmer triac circuit. The iron is set to maximum temperature and is now very hot. This iron pulls quite a bit more when it's cold, and I would say it has reached stabilization at this point. The waveform measurement AC RMS values are very close to what I measured with the true RMS multimeters. Since watts equal voltage times current, that is the math I want the scope to perform. I have the operator set to A times B. A is channel 1 and B is channel 2. And the scale is 10, I guess undefined units per division. In this case, that should be 10 watts division if I'm doing this right. Now this scope puts the math waveform in a different window, which really seems to be okay. I think I kinda like that better than all the waveforms being on the same screen. And I can close the main window and get a full screen of the math waveform. And it looks like peak instantaneous power is maybe 55 watts, very close to the 60 watts the iron is listed as. But now is where I'm not sure what measurement function should be used. The source for the measurement is the Math1 waveform, and my first thought is I want the average of the waveform, and that gives me a 22 watt reading, which is very close to the 23 watts I calculated from the RMS current and voltage, not only from the scope but also from the multimeters that I used. So that kind of makes me think this is the correct measurement function, but is it? There is also the VRMS measurement function, which is the RMS value of the waveform. Now it gives me over 29 watts, so quite a bit more power from that function. There is also the AC RMS measurement, and that gives me under 20 watts. I believe the only difference between the VRMS and AC RMS is the AC RMS does away with the DC component. So I have two questions here. Which is the correct measurement function to get the most accurate reading for the power being used by the iron? And does the VRMS showing a DC value mean that this is not a purely resistive load, and I'm suffering a power factor loss here? If you have any experience with this sort of measurement, I would love a comment on where I'm going wrong here. Well, all comments are welcome, and thank you for watching.